Electricity powers our world. We use it for everything. Understanding electrical loads is important. It helps us use electricity safely. It also helps us design efficient systems. This guide provides a beginner's look at electrical loads and circuits. Electricity can be dangerous. Always consult a qualified electrician for installations or repairs. Safety is paramount when working with electricity. This guide will introduce you to the basics. We will explore the different types of electrical loads. We will also learn about circuits. Let's get started. An electrical load is anything that consumes electrical energy. It converts this energy into another form. This could be light, heat, or motion. In simple terms, a load resists the flow of electricity and makes the electrical energy do work. Think of a light bulb. When you turn it on, it consumes electrical energy. This energy is converted into light and heat. The light bulb is the electrical load. Another example is a motor. Motors convert electrical energy into motion. They are used in many appliances. Examples are fans, washing machines, and refrigerators. Ohm's law is a fundamental principle. It describes the relationship between voltage, current, and resistance in a circuit. Voltage is the electrical force. Current is the flow of electrical charge. Resistance opposes the current. There are three main types of electrical loads: resistive, inductive, and capacitive. Each type interacts differently with the flow of electricity. Resistive loads are the simplest type. They directly convert electrical energy into heat. Examples include incandescent light bulbs, toasters, and electric heaters. Inductive loads create a magnetic field when electricity flows through them. They are found in devices like motors, transformers, and generators. Capacitive loads store electrical energy in an electric field. They are used in devices like capacitors, which are found in electronics for smoothing voltage. An electrical circuit is a closed loop or pathway. It allows electricity to flow from a power source to a load and back. Think of it as a path for electricity to travel. A simple circuit has four main components. These are a power source, conductors, a load, and a switch. The power source provides the electrical energy. The conductors or wires provide the path. The load is what uses the energy. The switch opens and closes the circuit. Circuits can be connected in series or parallel. In a series circuit, the components are connected one after another. In a parallel circuit, the components are connected in branches. Parallel circuits are commonly used because if one component fails, the others can still operate. Section 5. Characteristics of electrical loads. Electrical loads have specific characteristics that affect their performance. One important characteristic is the starting current, also known as inrush current. When some loads first turn on, they draw a much higher current than during normal operation. This is common with motors and incandescent lights. Another important characteristic is the power factor. The power factor indicates how effectively a load uses electrical power. Resistive loads have a power factor close to 1, which is ideal. Inductive and capacitive loads have lower power factors. This means they waste some power. Balancing the power factor is important for efficient energy use. Section 6. Real-world applications. Understanding electrical loads and circuits is essential for many real-world applications. For example, when designing an electrical system for a building, you need to calculate the total load. This calculation considers all the devices and appliances that will be used. This ensures the system can handle the electrical demand. Variable frequency drives, or VFDs, are used to control the speed of inductive loads like motors. VFDs adjust the frequency of the electricity supplied to the motor. This allows for precise control and energy savings. Load balancing is crucial in three-phase systems, commonly used in industrial settings. It ensures that the electrical load is evenly distributed across the three phases. This prevents overloading and improves efficiency. Section 7. Safety first with electricity. Working with electricity can be dangerous. It's crucial to prioritize safety and take necessary precautions. Always assume that electrical wires are live and handle them with care. Never touch exposed wires or electrical components unless you are trained and qualified. Use insulated tools and wear appropriate safety gear, such as gloves and eye protection. If you're unsure about any electrical work, it's best to consult a qualified electrician. They have the expertise to handle electrical systems safely and efficiently. Section 8. Conclusion. Understanding electrical loads and circuits is fundamental to using electricity safely and efficiently. By grasping the basic concepts of different load types, circuit configurations, and load characteristics, you gain valuable knowledge. Remember that this guide provides a basic overview. There's much more to explore in the world of electricity. Continue learning and exploring to deepen your understanding. Section 9. What's next? Electrical wiring. Now that you understand the basics of electrical loads and circuits, let's move on to electrical wiring. Electrical wiring is the backbone of any electrical system. We will explore different types of wires, wire sizes, and color codes. Understanding these concepts is essential for safe and correct electrical installations. Stay tuned for our next guide on mastering electrical wiring basics.